Section 1.2, Solving Multi-Step Equations. What we're going to be looking at here is expanding our discussion of solving equations to make them a little bit more complicated. We're going to be using all the same skills we did with the previous section, but now we're just going to be putting them together. First step in solving a multi-step equation, like we have on the right here, 5f plus 4f minus 8 equals 19, is if it's possible, we often want to simplify each side of the equation. Not always possible, but when it is, it's useful. So I look at the left side of my equation here, 5f plus 4f minus 8, and I see that I can combine some like terms there. The 5f and the 4f can be added together to make 9f, and that simplifies the left side of the equation a little bit. The right side of the equation, there's not much to simplify there since there's just a 19, and that's simplified. So that's kind of my first step there. Now my second step is to use inverse operations to isolate the variable. And so my goal is to get the f by itself. I want to be able to say f equals a number. That's the goal. In order to do that, I've got to get rid of this 9 and this 8. Now the 9 is being multiplied by the f, being right next to it. Sometimes you'll see a dot right there, or parentheses, but being right next to the variable means multiplied. And the 8, you can see, is being subtracted from the 9f minus 8. So I have to use inverse operations. To get rid of this 8, I'm going to add. To get rid of this 9, I'm going to divide. But I just have to make the decision which one to do first. And step 3 actually tells me what to do there. We actually typically reverse the order of operations when we're solving an equation. Order of operations does the work out for us, so to solve the equation, we're basically going back to the beginning. So rather than calling it PEMDAS, I call it SADMAP. You do addition and subtraction first, division and multiplication next, and then exponents and parentheses. You deal with it in reverse order. So here, our goal is to deal with the subtraction first. How do we deal with the subtraction? With addition. We add it to the left side of the equal sign, and the right side gets jealous, so we add it over there as well. This causes the minus 8 and the plus 8 to cancel on the left, leaving just 9f. And on the right side, 19 plus 8 gives us 27. And now we just have a one-step equation. So this is 9f, so it's 9 times f. So to cancel out that, we divide by 9 on each side. You can write it either like this or using a fraction bar. We'll cancel out over here, and it leaves you with f equals 3. And that's going to be our answer. Now we want to go back and we want to do step 4 just to make sure we're happy with what we've got. We want to check our work by plugging our solution into the original equation. So my original equation was 5f. Well, I want to make that 5, and then I'm going to plug in using parentheses. That's 3. Plus 4f means plus 4, and then in parentheses 3, minus 8. And we're hoping that this equals 19. I'm basically saying, is that true? And just do the math. Order of operations tells me to do 5 times 3 is 15, 4 times 3 is 12, minus 8, and hopefully again that equals 19. Going left to right with addition and subtraction, 15 plus 12 is 27. I guess I should probably still keep my question mark there. I haven't shown that it's true yet. And 27 minus 8 does equal 19. So does 19 equal 19? Yes, that's our check, which we've done here. This is our check here. And so that means is that f equals 3 is indeed our solution. There we go. Simple as that. All right, here are 3 equations that are multi-step. I want you to pause the video, try to solve each one of these yourself, and then come back to check your work. All right, let's see how you did. All right, and there you see our answers. First one, n is negative 3. This is from some subtraction and then division. And just make sure you're careful with negatives. Remember that a positive divided by a negative is a negative, and that you have to make sure you can see if you can reduce this. 6 over 2 does become 3. You don't need to write it as an over 1. I think that would be excessive. And you could, again, use a fraction bar or a division symbol, up to you. Middle one, negative 20 equals c, or c equals negative 20 if you're wanting to rewrite it that way. And the big key here is I had 1/2 c, so I multiplied by 2 over 1. If you ever have a fraction that's the coefficient of a variable and you're trying to isolate that, you just multiply by the reciprocal because you'd have to divide by the original fraction. So rather than dividing by 1/2, I'm multiplying by 2 over 1. Do that to each side and I get negative 20. And then finally the third one, x equals negative 1/2. When I'm doing division here, I have a positive over a negative, so I do get a negative, and 6 over 12 reduces to 1/2. You could write it as negative 0.5. That would be fine as well. All right. If you didn't get those, I would suggest trying them again and seeing if you ended up getting the right answer. Let's move on. One thing that we actually have is sometimes we get to choose which way we'd like to solve the problem, and we can either use the distributive property or not. It's kind of up to us. Let's look first if we were to use the distributive property here, which would mean distributing the 5 to the x and to the 4. Well, 5 times the x is 5x, and 5 times the 4 is 20, so I have minus 7 equals 13. And now I can go ahead and solve this equation, so I'm going to jump ahead and do that. And so you see I end up with x equals 0. Remember that when you have 13 minus 13, and that's the only thing left on the side, you do need the 0 as a placeholder, equals 0. And then dividing by 5, 0 over anything is just 0, except for 0 over 0, which is undefined, but that's something we can look at a later time. The other option I mentioned would be to hold off on the distributive property and instead basically treat this block here, the x plus 4, as something just by itself that we want to keep together and solve for that. And so in order to do that, I'm not going to touch that. I'm just going to try to get that part by itself. So in order to do that, what am I going to do here? I'm going to add 7 to each side to start off. And it's going to leave me with 5, and then in the parentheses, x plus 4 equals 20. Now I want to divide each side by 5. Again, just trying to get that yellow group of parentheses by itself. And now you can see that that leaves me with x plus 4 equals 20 divided by 5 is 4. And so now I can solve this because the parentheses really aren't necessary anymore. So I'm just going to get rid of those. And now in order to solve this, subtract 4 from each side. And you see what I end up with when these cancel. So I end up with the exact same answer, x equals 0. And so the distributive property is something that you can use. Sometimes you have to use it, but in this case, we could have also held off and waited. So either way would work. All right, hope you like having these two options. All right, let's take a look at one last word problem, and then we'll be done with this lesson. On the first 4 algebra quizzes of the year, you earn the following scores: 72, 80, 86, and 74. What score do you need to earn on your next quiz to have an average of 80%? So what I'm going to do is I'm going to take the information that I'm given. I'm given the first 4 scores, and I know there's going to be a next quiz, a 5th quiz, and I want to have an average of 80%. Well, I remember from vocabulary that average means I add up all of my scores. So I'm going to add up the 72, the 80, the 86, the 74, and I'm actually going to add in my next score, which I don't know, so I'm going to call that x. And once I add them up, I divide by the number of quizzes that I've taken. At that point, there will be 5 quizzes taken, and I want that average to be 80. That's what I want to have there. So now, in order to do this, I'm just going to try to solve the equation. I'm going to start by simplifying the numerator on the left side. And so I end up getting 312 plus x over 5 equals 80. Now, normally, we would think about trying to go through the reverse order of operations, so we would think subtract the 312, then multiply by 5. But if we do that, 80 minus 312 is going to be a negative number, and then multiplying that by 5 will keep it negative. I'm not going to get a negative score on my test or my quiz and then end up with an average of 80%. That's impossible. So what I have to remember is that when I have a fraction, in a sense, everything in the numerator is in parentheses. Same thing with everything in the denominator if things are being added or subtracted. So parentheses would actually be the last thing I'd touch in the reverse order of operations. So I'm going to take care of this by multiplying by 5. That will cancel out the divided by 5. And that'll leave me with 312 plus x equals 400. Now I just have the last step is subtracting 312, and when I do that, I get x equals 88. And so if I get an 88 on my final quiz, I'd have an average of 80%. I can check that by plugging that 88 kind of back into here, into my original equation. That's going to change this to be 312 plus 88, which is 400. And if I get 400 total points out of 5 quizzes, it's going to give me my average of 80%. All right, I hope that now you feel a lot more comfortable solving multi-step equations.